Hello there, and welcome to part 5 on this course on Unity Fundamentals. It's put together for the students at Saturday Academy, and I am the instructor for this course, Will Patillo. In this lesson, we're going to be making this little escape the box game we have going a bit more interesting by putting some collectibles in the room that the player has to walk around and pick up before this button becomes unlocked and something that the player can press. So if they just go there right at the beginning, then nothing will happen, but once they've picked up all the coins, then the button will become unlocked and then they can press it, open the door, and finally leave. So to get started with that, I'm going to create some objects to pick up, and I'm just going to create golden coins just as something fairly simple. So for that, I'm going to start by, and also before anything else, this organization of this is bothering me a little bit. I'm going to create an empty game object here, call it walls, and I'm going to throw all these walls inside here. And also one other thing, I don't know if I mentioned this before, but I have marked all of these walls as static, this little checkbox right here. This is generally a good practice to tick this box on any objects in your game that you know are not going to be changing. They're not moving, you're not changing their color and so on. It's just a way it allows Unity to take some shortcuts in its computation so that they take up less memory and makes everything in your game run a little faster. A game like this, you don't really need it because there isn't a whole lot going on, but just so you know what that box is for. Definitely do not tick this for anything that will be moving because then it eats up a lot more processing than it could save. So anyway, just a little something to know about. Anyway, when I get back into creating those coins, so I'm going to right click in this hierarchy and then create a new 3D object and of type cylinder. And I'll bring this over to 0, 0, 0 so I can see it right there. Alright, and here is my coin. And next, let's see, I'm going to shrink this down so that coins are fairly narrow. So let's say if I take this Y and I set it to 0.1, that's still a little thick. Let's go with 0.05, and I'd say that looks fine. Fine level of thickness. You could always shrink it down further if you like. I like 0.05. Next, we're going to rotate this. So I'm going to, you can see these axes right here. This is the X, Z, and Y. So let's see if I rotate it by 90 degrees on the Z axis. It's just turned around right there. So now it's facing upright, which I like. And I'm also going to shrink it down on all these. So let's say if I go with 0.5 in each of these, that's a nice good coin size. And actually, since those are smaller, I'm going to shrink this in half also so that it's a little thinner. Alright, and right here we can edit the collider. Unfortunately, I don't think there are really you only have a few options in colliders. If you look them up, you have box collider, capsule collider, sphere collider, and some others. Now, two options here: we could just leave it like this, or maybe even use a sphere collider that we could shrink down. Another option, if you really want it to be in the shape of a coin, you can remove that component and make a mesh collider and tick it as being convex, and now it'll be exactly coin shaped. So I have my coin. I kind of like this shape, but I want it to be a different color. So I'm going to create a new color, or a new material first, and I'm going to call this gold. And then I'll change the color with this little color picker, and getting a nice yellow color. So if I just remove the blue and go full red green, then that's yellow. But to make it golden, I find something around red 255, green 200. Looks, I think, will work pretty well. There we go. And you can always change the color if you like to make it look nicer. Okay, and I'm going to also rename this with F2 to coin. Put this in here. And so yeah, now I can move it around. Also, since I'm going to be creating several of these, I'm going to create another empty game object, and I'm going to call this coins. Put this up here and drop coin into it. Now I can take this, press Control D, and I can make several copies of it. Although I might be creating a prefab out of this, so actually, yeah, I'm just going to go ahead and do that now. Go into prefabs, drag in this coin. All right. So that way, if I decide that I want to make changes after I've placed a bunch of coins in the level, I won't have to search for all of them and apply the change individually. I can just modify the prefab. All right. So I have this coin, and I'll go ahead and, now that it's a prefab, I can go ahead and duplicate and make several of them. One thing you might notice, by the way, the color of this text, see, if it's in blue, that means it's a prefab. Black means it's just a untied scene object. And if you see something in red, then that means it is a prefab, but its connection to the resource has been broken. It'll still function. You won't get errors. It's just its prefab behavior might be a little off. So that's 6 coins. I'm going to go ahead and actually just get rid of one of those. And so that the naming is consistent, I'll just call this first one 0. Okay, so now I have these coins. It still looks like I only have one. That's because they're all on top of each other. So if I start picking these one at a time and move them about, then I can see that there are actually several coins. Okay, and I'll just leave them all together for now. For testing purposes, we can spread them out in a more interesting way later. Alright, now the next thing is that these are going to need to do something when the player walks into them. Namely, they need to disappear, they need to register themselves as having been collected, so that the list of things that need to be collected gets shorter. And we won't be covering this now, but you know, if you continue to expand this game out, you might want to also add them to an inventory or something. So yeah, so let's go into the prefab, and since something needs to happen when the player walks into them, that means we're going to bring out our what did I call it? Yes, our contact event. And by the way, I'm working in the prefab now, which I got here by pressing this little arrow. So on contact, then the coin is going to disappear, which I can make that happen by just going into game object, set active false. Just for the sake of testing, I'll go ahead and try that out. I'll press backspace, go into third person view. Oh, right, because I'm running into the coins rather than walking through them. So also this contact event assumes that the objects are a trigger. So go back into the prefab, click is trigger. Let's try this again. Okay, and I walk into a coin, and when I touch the coin, it disappears. Okay, so our contact event and our trigger is working. Okay, next thing, going to go to this button, because we only want it to activate when we've collected the coins, and I'm going to create a new script, and I'm going to call this C# script collect all event. Open this up. Okay, bring up Visual Studio Code. You could use whatever code editor of your choice. get rid of these boilerplate methods. Serialize field, and with the list, I'll explain why I'm using a list instead of an array a little bit later. Game object, collectibles equals new list game object. And don't worry about this right now, just type it in and I'll go over why you need it later. And we're also going to need a serialize field so that it's available, Unity event, and on all collected. Okay. Right. Oh, and then because we're using Unity events, using Unity engine dot events. So let's take a look at Unity and see the inspector, what's going on. So if I go into coins, or actually, sorry, if I go into button container, and add component, collect all events, we can now have this little drop down here. This is our list, and I'll make it size 5. And now 5 of these show up. And then I can just drag in each of these coins. Okay. So now that dragging these items in fills our list of collectibles with these 5 coins. Next, and then in this on all collected, then we need to have something happen, which is going to be to unlock the button. But the button doesn't have a lock yet, which I just realized. So let's go into our button and into this contact event. Right now, it always invokes this on contact when the trigger event happens. So we need to put a condition here. So for that condition, I'm going to create a little serialize field and boolean, and I'll just call this locked. Then, in this on trigger enter, if not locked, then we can invoke this on contact event. So if I go back into Unity here, and I take a look at this button, I look at the contact event, a new checkbox showed up, and so I'll just tick this for the button because it's locked at the beginning of the scene. However, for the coins, their contact event gets updated also with this locked checkbox, and I'm going to leave that unticked so that the player is not prevented from picking up the coins. So we can see that in action. I'll press play, go into third person, and yes, I can still pick up the coins as I could before, but when I touch the button, the door does not disappear because the button is locked. It's not interactable. Now, one thing I'd also like to just point out why I'm using a serialized field here rather than a public is my goal here is to change this locked variable from the collect all Unity event. And it would be really nice if I could just set it directly. So if I go into button container and I went to this on all collected, drag in the button, and look at the contact event, there are some variables that I can just directly set, like whether the script is enabled, and I suppose I could use that instead of using a variable, but let's set that aside. But that locked, even though it's public, doesn't show up. So the way I'm going to be able to change this variable is I can just create a new method here. Public void set lock, and bool is locked, and now I can just say locked equals is locked. Okay, and so now if I look back at this on all collected, I can go to my contact event and use a set lock and untick this. So once all these are collected, then that will set the lock on this button. It'll just untick it right there. Now, because this locked variable is being set through code that's internal to this class, it's not necessary to access locked from another script. It's all just done internally, so I can keep it as a private variable, but I still need it exposed in the inspector, so if something's exposed in the inspector but not exposed to other classes, then serialize field is the best practice way to set it. One other convention I'm just going to throw in here, and not everyone agrees with this convention, but I kind of like it, is I'm going to call this variable that's being passed in locked, because the purpose of this variable is exactly the same as what I'm using here. However, if a variable that's local to the method has the same name as the variable that's used throughout the class, then you have to differentiate them. And since I'm using this local variable to set this global variable, a way I can do that is to use this dot. So this means that you are referring to something that is in the class. And actually, it's something that that the code has been using a lot, but just implicitly. So as an example, if I were to want to say that set the game object inactive, I could typically say game object dot set active false, and that will set the game object that this script is attached to be inactive. And one thing that is actually happening from the computer's perspective is this is what's actually happening. There's a this.gameObject.setActive. Set the game object that is attached to this script, that this class is attached to. However, to save you some time, the language will just assume that if you leave that blank. For the same reason, by the same token, if I wanted to do something with the transform, I could just write transform dot whatever method I want. I'm working with maybe position or whatever, and technically what's happening there is this dot game object dot transform. Same things for get component and so on. But a lot of that stuff's just implied because to save you a little bit of typing. Anyway, that's a little bit of a tangent, and that's what if you ever see this in code, that's what's going on with it, and it also allows you to reuse some names when which can be nice if they're referring to the same concept. All right, so now I have my way of setting this lock variable, and all that is needed is the actual code that determines when this onAllCollected Unity event fires. So if I go back into my collectAll event, I actually need some code. So what's going to happen here is every time a coin is collected, I'm going to remove it from this list. And once the size of the list is 0, then I will fire this event. So I'll deal with that right now. Public void remove from collection. And then I just say, since this is a list of game objects, I'll say game object item. So this is the item that's being removed. And actually, just to be clear about it, I'll call it item removed. Then I can just say collectibles dot remove item removed. That will remove it from the list. Now I can just look at the length of the collection by saying if collectibles.count is less than or equal to 0, then on all collected.invoke. And to be able to use this remove is why I'm working with a list. And a list is like an array, except it has a bunch of added really nice features, such as being able to add and remove items to expand the size of the list. An array has a fixed size, and you just have to work with that. I mean, you can fill in items or make them null or so on, but you can't really change the size of an array once you've created it. And that there are a lot of occasions where someone wants to change the size of a collection. So some really good programmers in earlier computer science created this thing called a list, which allows for dynamic resizing. And list is defined inside of system.collections.generic, which is why we need this library whenever you want to use list functionality. This part here creates space in memory. This constructs the list, but at this point it's still an empty list of size 0. And then with the serialization, we're able to add items to it, so now it's a list that has 5 in it, and then we can remove items and then check how long it is. Alright, so that should be all the code that we need. The one thing that's left is to actually call this remove from collection. So for that, I can just go into this coin, and in this contact, add a plus, and drag in this button container, and go to this collect all event, and click remove from collection, and then pass in itself. So when the coin is touched, in addition to deactivating the game object so that it isn't visible and you can't collide it with it anymore, this line will then cause it to be removed from this list. Now, one thing that would be kind of nice is since this has to be repeated for all these coins, I'd like to see what happens if I try to make that change on the prefab level. So if I go in here and I go with a plus, and oh wait, there's a problem. I can't drag in that button container. And the reason for that is a prefab is a resource that is not connected to any scene, whereas that button container is something that exists in the scene, so I can't really get a reference to it on the prefab level. So unfortunately, what that means is I need to make this assignment on every single coin. So just to make that a little quicker, I'll just click the first one, shift, click all the way down to the fourth. Now drag in this button container and go to this collect all event and click remove from collection. And now for assigning these, it's a different coin for each of them, so that one has to be done one at a time. So just drag it, so select coin 1, drag it in here, coin 2, drag it in here, coin 3, drag it in here, 4, and there. So now each coin is responsible for deactivating itself and removing itself from this button container list. So now to watch what's happening, I'm going to keep this button container selected as I play the scene, and I'm going to go into third person here, and I'm going to move around, and as I touch this coin, notice the list just shrank down. There's one less item in it. Also, I'm going to watch the button and watch this locked. So as I collect all the items in the list, see, it's still ticked, and then I get this last one, and then the tick mark goes away. And now I can press the button and the door opens. Now, the one more thing that I want to add to this before I finish with today's lesson is to create a little bit of user feedback to tell the player that the button is locked at start, and then so that they see something change about the button when it becomes unlocked. Because otherwise they might be, you know, walk over here, they touch it, nothing happens, and they figure, all right, well, maybe that's just decoration. And they walk around, they pick up the coins, and then don't realize that picking up the coins unlocked the button, so they don't think of going over there, and they get stuck, and they get frustrated. So giving feedback when the state of the game changes is always good game design. And the way I'm going to deal with that is just by changing the color of the button. Now, the simplest way to do this would be to just go into my on all collected and click the plus, and then drag in this button, and then go over here to the mesh renderer and just click this material option and select this, and then just say click the blue. So this will swap out the existing red material for a blue material when all the coins are collected. So let's just take a look at that. Okay, collect the coins. Now I get this last one, and now the button just turned blue, and then when I touch it, it still goes down. That works the same as before, and yeah. So that works, and it's nice and simple, and it might be what you want to go with. However, swapping the materials on objects is a little inefficient from a processing kind of standpoint, because all I really want to change is the color. And unfortunately, I can't just access the color directly through these Unity events. I'm going to need to be able to create a new script that exposes color on the button and work through that. So create new C# script, and I'm going to call this color changer. And it's it's going to feel like a lot more work than just setting a material, but you do it once and then it becomes just as easy. Alright, so I got my color changer here, and this is going to need to what's going to need to happen is on this button I'm going to need to access this actually more specifically, what I'm going to need to access is this right here. So this is the color of the material, and the material is stored in the mesh renderer. And the mesh renderer is what's actually attached to the game object. So to change the color, I need to start by getting access to the renderer. And I'll just create a variable here, renderer, and say that 5 times fast. Private void awake. So this right here, I just created space in memory for a renderer. Now I need to actually get access to it. Renderer equals get component. Okay. So right here, this gets access specifically to this mesh renderer component. And also, by the way, this get component, this is the same implicitly as if I said this .game object .get component. The compiler will just change this line into this, but if you don't include it, then it'll just assume that. Okay, so now I have access. Now I can say public void set color and int index, and by the way, I'm using right now basically the exact same logic as I was using, remember this fixed point movement, where I was using a jump to position. I'm essentially doing the same thing, but with colors. So I can actually just copy this logic and here, and I'll change jump to position to set color, and instead of a array of locations, I'm going to have an array of colors. So let's declare that color, use brackets to make it an array. Oh, and also serialize this. Call it colors. And now I can just swap out this locations with Control C and replace the locations with colors, because I have a different name for this array. And I'll change cycle position to cycle color. All right, and set color. Okay. Right, and now instead of setting the position and rotation of a particular transform, I'm going to say renderer.material.color equals colors index. Okay. And yeah, then I'll just keep this so that it'll sync with cycle color. I'm not actually using cycle color right now, but I might later, so why not? And now, if I take a look at this button, and all right, I'm gonna see console errors. Current index does not exist in. Oh, right. I also need a int current index equals 0. Actually, you know what? I'll just make it completely like fixed point movement and throw in a starting index. Okay, and color changer. Yeah, may as well make these exact. I don't know that I'm going to need that functionality, but I might, so might as well add that in. And then I'll just also copy the start method. Here, private start, if starting index is greater than or equal to 0, set color starting index. Now, one thing I could do here, and this would technically be a little bit more efficient, is I could copy these and put them in awake, because start and awake have very similar purposes. They both fire as soon as the scene opens if the game object is active, and if the game object is not active when the scene starts, then it waits till the first time that's enabled. The only real difference between awake and start is that awake happens slightly before start in execution order. And I like to use awake and start for different purposes. It can make life a little easier and prevent certain types of errors. I tend to reserve awake for setting references and start for initializing, so that if just in case something that's happening in the initialization depends on something being a reference being set in a different script, I'll know that the reference setting happens first, and I'm less likely to get a null reference exception. So anyway, just as a little aside there. So now, that should take care of those errors. See them go away. Do I need to save? Oh, that's because I still haven't set as a variable int current index. Okay. There. Should be good. Oh, and then also just to keep these a little separated out. Okay, put some spaces there. All right. Now let's see if the variables see if those compiler errors are gone. Great, they are. Okay, so now that those are all gone, I can attach this color changer to the button. Okay, and I'm going to give it 2 different colors. I'm going to make element 0 the red color, and make sure that the alpha is 255, and then element 1 I'm going to make it blue 255, alpha 255, and yeah, I'll go ahead and give it a starting index of 0 so that it starts off as red. Actually, one thing I'm just also going to throw in here, starting index is -1. So when you set something in code that's also serialized, this will just kind of give it a default value until a developer changes it. So when I create new things that have this color changer script attached, it'll just be -1. So if I forget about this, it'll not have any impact. Could prevent some errors later. And for this one, though, I can leave it at 0. All right. So now that I have this color changer that is able to access through this line here the color of the material of the renderer, I can now call this set color right here. So in this on all collected, add a little plus, drag in the button, look for the color changer, and then say set color, and I'll give it 1 because that is the index of the blue color. All right, so now this does the same thing as before, where the button turns blue, but now I'm just setting the color directly rather than messing around with materials. And I won't have to repeat any of that work because I now have this color changer script, and I can just attach it to anything else where I need to set the color, and it will work great. And I won't have to create lots and lots of individual materials for every single color I could possibly want. Okay, so that will be all for today. This video is getting a little bit long. Feel free to add some more coins, mess around with them, try. We have a bunch of general purpose scripts that can enable, disable things, can interact, move things around. We got teleports, we got collectibles. So I'd recommend taking a break before watching the next video and see what kind of level you can create with just the things that the components that we've built so far, without necessarily adding any new code, although you're certainly free to experiment with that as well. I'm, in fact, highly encouraged. In the next video, we're going to add a nice little bit of visual polish to this game by adding an animation to these coins, causing them to kind of spin around in the air and also to bob up and down. It'll make them look a lot more coin-like. Right now they're a little static. So hope you enjoyed this lesson, and thank you for watching, and I will see you in the next one.